Hello, and welcome to this video on energy stores and systems, where we will be talking about the current model for energy, which is the energy stores, and how energy is transferred in between those stores. Energy is an abstract concept. It's a number that can be calculated rather than a thing that exists. This makes it really difficult for our brains to understand, so we use models to help us. A model is something we have created that helps us to imagine what is happening. Models are very useful, but they are far from perfect. The current model for energy involves labelling energy as stores. Energy is kept in a store until it is transferred to another store. None of the energy is lost. It's always accounted for. It is always transferred into another store. You need to know about the following energy stores. The kinetic store. Anything that is moving has a store of kinetic energy. The gravitational potential energy store. Anything that has the potential to fall has gravitational potential energy, so any mass in a gravitational field. Elastic energy. Anything stretched or compressed has this type of energy. Thermal energy. The hotter something is, the more energy is in that store. All objects have thermal energy, even the ones that you consider to be cold. Chemical energy. Anything that can release energy via a chemical reaction has chemical energy. There are also energy stores that are less likely to come up in an exam, and these are electrostatic, magnetic, and nuclear. The electrostatic store is the energy stored in between charged particles. The magnetic store is the energy stored between North and South Pole, or North and North Pole, for example. And the nuclear store is the energy that is stored inside the nucleus of an atom. To help us understand how the energy model works, we can use beakers to represent the stores and water to represent the amount of energy. In this example, we will look at the pendulum. When a pendulum swings, it moves from a position where it has a greater height to a position where it has a lower height but a faster speed. This involves an energy transfer. The energy transfers from a gravitational potential energy store to a kinetic energy store. As the pendulum continues to swing, the kinetic store transfers to a gravitational potential store. This is shown by the water transferring from the gravitational potential beaker to the kinetic beaker and back to the gravitational potential beaker. Notice that all of the water is accounted for, none of the water is missing. This is the same for energy. It should always be accounted for, none should be missing. When energy is transferred from one store to another, there is a mechanism in the model for this to happen. Energy can be transferred in the following ways. Mechanically. This transfer involves forces, for example pushes and pulls. Electrically. This transfer is when charges move due to a potential difference, for example current in a circuit. Heating. Hotter objects transfer energy to colder ones. And radiation. Light or sound waves transfer energy in this manner. So each time energy moves from one store to another, it does so via one of these four pathways. For example, a toy rolling down a ramp. In this example, energy is transferring from a gravitational potential store into a kinetic store. Assuming that there's no friction, none of the energy will go into the thermal store. This happens due to gravity, which is a force, so the transfer is a mechanical pathway. The transfer of energy can get complicated, so to keep it manageable, we use systems. A system is a single object or a group of objects that we are interested in. For example, a ball falling, or an electric motor in a lift moving upwards, or a child on a trampoline. A closed system is a system where it is considered that no matter or energy can enter or leave that system. In our previous examples, the systems were in the pendulum, the string and the pendulum bob are a system, and in the toy car, the car and the ramp are considered to be a system. And that's the end of this video. Thank you so much for listening.